So hello students. So good afternoon. Good afternoon everyone. Yeah, it's perfect. Is it okay? You two friends. Hi, good afternoon. Then so students in the Zoom meeting, good afternoon. Okay, so we are studying about organic chemistry, right? So organic chemistry, some basic principles and techniques. So that is our chapter. So simply we will call it as GOC. So we have finished IUPAC nomenclature. Then after that, we are studying about electronic displacement effect. Yeah, JNV Daman. Okay. Welcome to the class. Is everything fine technically? So let me know if everything is fine. Then give me some thumbs up or okay, perfect or something. The chat box you can give the reply. So chat box, I'm waiting. Okay, I hope everything is fine. Technically, everything is fine. So it's already 3 o'clock. So without wasting time, so let's start it. Okay. So last class, we were studying about electronic displacement effect. Okay, Jen, yes, sir. Okay, right. So that's a spirit. So that's a spirit I want. So we are studying about electronic displacement effect. So I think last class was on Tuesday, right? So long back, so many days. So we will just revise what are the things that we have studied in electronic displacement effect. Okay, so we know there are different types of electronic displacement effect. First one is inductive, second is hyperconjugation, third one is resonance effect. Resonance you have studied in chemical bonding chapter. So it will be very easy for you. You have already studied that the basic things about resonance. We will repeat the things, same things, and we will add some points also. Okay, then inductive effect. Right. So inductive effect, it is like our electronegativity. In third chapter, you have studied electronegativity. Similar kind of thing. Inductive effect. We have studied inductive effect. There are two types of inductive effect, plus side, minus side. Right. So inductive effect is so one guy is pulling the electron towards that. So that will get partial negative charge. Other will get partial positive charge. Polarity is developed. So it is happening in sigma bond, not in pi bond. Then this is distance dependent. And there are different names for inductive effect. Okay. So for this carbon, there is higher effect of inductive. Just a second. Okay. Then as a distance increases, the inductive effect decreases. So I can say it is a weak effect. It is a permanent effect. So inductive effect that is proportional to 1 by distance, inversely proportional to a distance, right? Then after that, we have studied minus I effect, minus I, negative, right? So they are taking electron from the carbon chain. So negative people, they are not good people, they are villain, right? Then there are different examples for electron withdrawing groups. We have studied NH3 plus, then C triple bond and fluorine, chlorine, bromine. So what about the order? Fluorine, chlorine, bromine. So electronegativity minus I, that is proportional to electronegativity, right? So fluorine has higher electronegativity, so higher minus I effect for fluorine. Then we have discussed charge also, positive charge. So positive charge, they're deficient of electron. So they will take electron from other species, that is minus I, electron withdrawing groups. Then we have studied different points about minus I effect. So these are the different points. Positive charge, that is proportional to minus I. Electronegativity, proportional to minus I. Then polar pi bond, then hybridization also. We have studied all these things in the last class. This is just to recall the things what we have studied in the last class. Okay. Then after that, we have studied positive inductive effect. They are good people. They are ready to donate electron to the carbon chain. Then the point is positive charge, that is proportional to minus I. Then here we are studying about plus I effect, right? So that is proportional to negative charge. So plus, minus. Okay. Then we have studied different groups showing plus I effect. So they are ready to give electron to the carbon chain. So these are the different groups. Then different isotopes of hydrogen, protium, deuterium, tritium. Due to isotopic effect, tritium has higher plus I. Okay. So this also we have studied. This was our homework question. So can you tell me the correct answer? What is the correct answer for our homework question? Okay, Alima is here, JNV Pune, Then yes, Mina. Okay, great. So can you tell the correct answer? Okay, someone is. Yeah, Lima, that is correct. So minus I, what we have to check? Minus I, that is proportional to electronegativity. So here we have fluorine, then oxygen, then nitrogen. We have already studied the order of minus I effect. So this is the correct order. So that was the homework question for you. The correct option, that is A. This is in 2018. It is also asked in 1998. Okay, so twice repeated. This is a repeated question. So that was our homework question. Okay. Then after that, we have studied breaking of bonds, right? So there are two types of bond cleavage. How to break the bond? There are two types. One is homolytic cleavage. Second one is heterolytic cleavage. These are the two types of cleavage of bonds. This one also we have studied in the last class. So just to recall the things. Then homolytic cleavage of bonds. What is that? So what is formed after the homolytic cleavage? Homo, same. So two people, they have started a business. Then after that, they are stopping that. Then money is equally distributed between these two. So there are two electrons. So one electron is going to this A, one electron is going to another atom. So I can say there is a free radical from A, then electron. That is known as free radical. Suppose atom is carbon with free radical. So we will call it as carbon free radical. So how free radical is formed? It is formed by the homolytic cleavage of bonds. So equally divided that money. Okay, then fish hook arrow, we have studied that. Free radicals are formed. How it is formed? We will study it later. Already I have explained that by radiation, then peroxide, then heat up to 500 Kelvin. These are the different things that we have discussed. Then reaction intermediate. What is this reaction intermediate? Suppose we have reactant. So we have reactant. It is getting converted to product. So it is not directly getting converted into product. Suppose Pune students, they are coming to Kanyakumari. So in between, there is a station called Udupi. So in Udupi, I am here in Udupi, okay, Udupi station. So they are not directly going into Kanyakumari. There is some intermediate present. So similarly, in chemical reaction also, some intermediate species are present. Okay, like an intermediate station, Udupi railway station. Okay, so what is this reaction intermediate? So I can say they are the species formed and consumed during chemical reaction. So finally, we are not getting this reaction intermediate. It is formed during the chemical reaction. It is also consumed during the chemical reaction. Okay, suppose Alima is saying that I want this intermediate. Then if you want, you can isolate that intermediate. Then we can study about that intermediate. So reactant to product. There are in between some species, they are known as reaction intermediate. So species forming and consumed during chemical reaction is known as reaction intermediate. There are different types of reaction intermediate. So we have to study. So we have already studied about one reaction intermediate. What is that? So first reaction intermediate, that is free radicals. So we have already studied free radicals. So can you tell me how free radicals is formed? By homolytic cleavage or heterolytic cleavage? Anyone? Homolytic or heterolytic? This free radical is formed by, okay, there are so many participants today. Okay, JNV Mahi students. Yeah, great. Then chat box, my chat box. Yeah, Yasmina, homolytic cleavage. Then there are some other reaction intermediate. How they are formed, we have to check that also. So next reaction intermediate, that is our carbocation. So what is next one? Carbocation, carbon positive charge. Next one is carbanion, carbon negative charge. We have already studied this. How this carbocation and carbanion is formed? By homolytic cleavage or heterolytic cleavage? What about the others in the chat box? The chat box should be highly active, hyperactive. Okay, so you two friends, you can also give the answers in the live chat. So carbocation and carbanion is formed by homolytic cleavage or heterolytic cleavage. Yeah, again, Alima. Yeah, Yasmina also. It is formed by heterolytic cleavage. We have explained that one also. Then there are some other intermediates also. It is not that much important for us in the higher class. We will study about that. There are carbenes, there are nitrines also. We will study this carbenes and nitrines later. So for the time being, we have to focus on free radicals, carbocation and carbanion. That is very important. okay, in chemistry. Then we will study about these three. So first one is free radicals. So what is this free radical? So I have a carbon, okay, homolytic cleavage. So one electron is coming here. So this carbon has three bonds. One, this is first bond, second bond, third bond. Okay. So carbon with three bonds plus one. What is present? One electron is present here. Okay, it is not lone pair. Pair means two electrons. So I can say one unpaired electron. So carbon with three sigma bonds and one unpaired electron, that is a free radical. So it is formed by the homolytic cleavage. Then we have studied about hybridization, right? How to find hybridization? Hybridization H is equal to number of sigma bond plus number of lone pair. There are no lone pair, okay? There is one unpaired electron. No need to consider it now. So how many sigma bonds? 3 sigma bonds. So 3 means what is hybridization? sp2. sp2 hybridization means what is the shape? That is trigonal planar. So free radicals, that is trigonal planar. This is very important point. So what is shape? Trigonal planar or a free radical? Okay, then some more points about this one, sp2 hybridized. So we have found the hybridization using our rule. Then it is electron deficient. So look at here, there are 2 electrons. Here also 2 electron. Here also 2 electron. Then one unpaired electron. Okay, so count the number. So octet is not complete. So it is electron deficient. Suppose someone is coming and giving some electron to that. So it will help our free radical to obtain octet. Okay, to attain octet, it will help. So if someone is giving electron, that will be very helpful for our free radical. So it can attain more stability if it is getting some electrons. Okay, then there should be some donating group present. If some donating group is present, then the stability of our free radical will increase. Octet. Okay, octet means stability increases. Yeah, that is an old concept. This is electron deficient, right? So there is no octet of electron. So I can call it as electron deficient. Then this point, acid require only one electron. Okay, so one electron is required. So what is this Lewis acid? So can anyone tell me Lewis acid? In chemical equilibrium chapter, chemical and ionic equilibrium chapter, we have studied. What is this Lewis acid? Lewis acids are, anyone in the chat box, Lewis acid. If you have studied, you can tell me what is Lewis acid. So Lewis acid, okay. So you can tell me in the chat box. Yeah, they are lone pair acceptors. Lone pair acceptors. Lone pair, it is a pair of electron, right? It need only one electron. So we cannot say it is a Lewis acid. Lewis acid are lone pair acceptor. Good admin, good. I don't know who is this admin, from which JNV or which school. Okay, so this is the details about free radical. It is sp2 hybridized, trigonal planar, electron deficient. It needs one electron. It's not considered as Lewis acid. Okay, Lewis acid, they are lone pair acceptors. Lewis base, we will study about that also. Is it clear about free radical, the shape of free radical? Is it clear to you, the shape of free radical? Yeah, admin, okay. Others. So look at here. So yeah, Lima, okay, great. Here we have a carbon, then hydrogen is attached, hydrogen is attached, hydrogen is attached. So what is the name of this free radical? I can call it as CH3 free radical. That is our methyl. So methyl free radical. I'm writing FR, okay. Then what about primary free radical? So I have carbon, then one hydrogen, then second hydrogen. Then this carbon is attached to one alkyl group. You can write it as CH3, that is methyl group. So this is known as a primary free radical. So how to write the secondary free radical? So I can write carbon, then R group, then one more alkyl group, then one hydrogen, then free radical. So that is known as secondary free radical. Secondary free radical. So how to write the tertiary free radical? That carbon should be attached with three alkyl group. So I can write it as R, C, R, then free radical. This is known as tertiary free radical. So these are the different types of free radical. Based on inductive effect, we will study which free radical is more stable. So why? What is the reason behind that? We will study about that. I have already given the hint. We will study that later. Okay. So homolytic cleavage these free radicals are formed. So that is a reaction intermediate. Okay. So next one, we have studied hydrolytic leverage. Okay, Alima. So we have studied hydrolytic leverage. That is A and B. They have done a business. They are stopping that. Okay. Then B is taking all the money and going away. So B will get one extra electron. If it is getting one extra electron, I can say it will become B minus. What about A? A is giving the electrons. It's not giving, other is taking the electrons, right? So A plus. So if there is positive charge on carbon, carbocation, negative charge, carbanion. So we have studied this one, how this hydrolytic cleavage takes place, how this carbocation and carbanion is formed. Okay, so carbocation, we should study about carbocation. So look at here, carbocation, that means positive charge is present. So positive charge is present on our carbon. Then how many atoms are attached to this carbon? That is one hydrogen, second hydrogen, third hydrogen. So can you tell me the name of this carbocation? Last case, I had told that, right? So what's the name of this carbocation? Is this methyl, primary, secondary, tertiary? Which one? JNV Pune students, JNV Mahi students, Alima, then our admin, then Yasmina is there, Babulal sir is there, JNV Kadapa, they have finally joined. Okay, great participation from your side. So can you tell me this is methyl or primary, secondary or tertiary? Anyone? So there is one hydrogen, one hydrogen, one hydrogen. So I can call it as methyl. I can call it as methyl carbocation. I'm writing CC. Okay, that is our carbocation. So you have to understand that. That is carbocation. That means so carbon. It is forming 3 bonds. Then positive charge is present. Okay, carbon 3 bonds, positive charge. That is our carbocation. How it is formed? By the hydrolytic cleavage of bonds. Then there is a positive charge present. Then we have to find the hybridization. How to find? There are no lone pairs. So I can say number of sigma bonds. How many sigma bonds are present? That is, you can see here, 3 sigma bonds. So can you tell me the hybridization for this one? Carbocation. What is the hybridization for our carbocation? Anyone in the chat box? So I'm waiting for your answers. So the chat box should be active. Yeah, Alima, great. So we have sp2. If it is sp2, so what is the shape of our carbocation? Again, Alima, JNV Kadapa, JNV Mahi students, JNV Pune students, anyone can answer. The question is open to all of you. sp2. So we have already studied chemical bonding chapter. sp2, yeah, Yasmina, great. So Alima and Yasmina is scoring continuously. So that is great. So the shape is highly unstable, sp2 hybridized. It is also electron deficient, right? So you can count the number of electrons. So it is electron deficient species. Then there is an empty orbital. You can see an empty orbital also. So you can count the number of electrons in this bond. You can check it's 2, 4, 6. So you can accept a lone pair of electron. If it is ready to accept a lone pair of electron, lone pair, then we can call it as a Lewis acid. What about free radical? We are not calling them as Lewis acid. So these are the important points. Then shape, that is planar. Our carbocation, that is planar in shape. So planar. So you have to remember this point next year also. Carbocation, planar, then sp2 hybridized. So that is our carbocation. So what is remaining? So we have to study about our next intermediate. Before that, you know how to write. So primary carbocation. So I have carbon, H, then plus charge. Okay. Okay, Esmina, you can type it in the chat box. So what is that? You can type it. So this is our methyl free radical. So methyl free radical is present. Second carbon, then one R group, then H, then positive charge. Okay. Okay, it will be disturbance for the others. Some other students, some issues will be there. That's why. So this is primary free radical. Next one, CR, R, then H, then plus, that is secondary free radical. Sorry, not free radical. We are discussing about carbocation. I'm still reading the messages. Okay, that is why. So here it is carbocation. So next one R, then R, then R. It is attached to three alkyl groups, then plus charge. So tertiary carbocation. So we will study about the stability, the order of stability for this different carbocation. Okay. Okay, fine, fine. So next one is our carbanion. So next we have carbanion. So carbanion means, so we have three bonds, then negative charge on carbon, then this is the negative guy, right? So it is taking all the electron. So there is a lone pair of electron present. So carbanion, lone pair of electron. So how to find the hybridization? How to find the hybridization? Okay, okay. Last at the end of the class, I will do it. No issues. Okay, it is sp3, Alima. Great, great, great. So it is sp3 hybridization. So it is sp3 hybridization. How to find? So number of sigma bond, that is 3 plus 1 lone pair, that is 4. Hybridization 4 means that is our sp3. So what is the geometry of this one? So what is the geometry? Anyone? So what is the geometry of this one? So geometry, not the shape. Okay. So what is the geometry? You have to tell me the geometry of this carbanion. So it is formed by the heterolytic cleavage of the bonds. So it is a negatively charged. Carbon has a negative charge. Then after that, highly unstable. It is sp3 hybridized. Then it is electron rich. So it is ready to give electron to others. It is a rich guy. Then it is acting as a Lewis base. So Lewis base means they are lone pair donors. It has lone pair. It is ready to give electron to others. So it is known as Lewis base. So it is a concept introduced by Lewis. So it is also nucleophile. So it has negatively charged, right? Electrons are present. So it is negatively charged. So it is nucleus loving. It is nucleus loving. Nucleus loving means that is positive charge. So nucleus loving. It has negative charge. So it wants a girl with a positive charge. Okay. So it is nucleophile. It is acting as a Lewis base. So this is all about carbanion. So again, you can write the primary, secondary, tertiary, and methyl carbanion. So using inductive effect, we can explain the stability of this carbanion. So that is the main objective of today's class. Okay. So reaction intermediates we have studied. So carbocation, carbanion, and free radical. Carbenes and nitrates, we will study that later. Okay. So how to explain the stability of carbocation? Carbocation means positive charge, right? So positive charge. If charge is present, what about stability? If charge high means stability is very low. So I can say the charge and stability, they are inversely proportional. They are inversely proportional to each other, the charge and stability. Then, so let us study about that stability that is proportional to electron deficiency, that is proportional to plus I, that is inversely proportional to minus I. Okay, confusion, right? So let us take an example. Then it will be pretty clear to you. So first I have carbon, hydrogen, 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 3 hydrogen, right? So it's a methyl carbocation. So this is our methyl carbocation. So second one, we have primary carbocation. Next, we have secondary carbocation. Next, we have tertiary carbocation. Okay. So can you tell me this CH3 group is attached here? Here only hydrogen. So this CH3 group, alkyl group or methyl group will show plus I or minus I. So can you tell me that? So CH3 group plus I or minus I, which one? So which one is shown by our CH3 group? Others, Alima, Yasmina. So CH3 group, it will show plus I effect, right? So it is ready to give electron to our carbocation. So if positive charge, if charge is present, stability is very low. So if the charge is decreased, then stability will also increase, right? So here we have CH3, it is giving electrons, it is giving electron to this carbon. This CH3 is also giving electron to this carbon. Then third CH3 is also giving electron to carbon. So electron negatively charged, right? So it is going to that carbon with positive charge. So we can say the positive charge will be reduced. If the charge is decreasing, stability increases. Then let us check the secondary carbocation. There are 2 methyl groups. It is giving electron to carbon. This is also giving electron to carbon. What about hydrogen? Hydrogen will show plus I effect, but we can neglect that. So there are 2 CH3 group. There are 2 CH3 group. There are 3 CH3 group. So 3 CH3 group is giving electron to our carbon. So positive charge will be decreased. Charge decreases, stability increases. So what about the primary carbocation? Only one CH3, right? So this CH3 group is giving electron to carbon. So charge decreases, but not that much compared to tertiary. Then what about methyl carbocation? Only hydrogen is present. So hydrogen, it has poor plus I effect. We can neglect that. So there won't be any change in the positive charge present on the carbon. So you have to remember, charge is inversely proportional to stability. So can you tell me, methyl, primary, secondary, or tertiary, which one is more stable? Depends upon charge. Okay, charge low, stability high. Anyone? Methyl, primary, secondary, or tertiary? So which one is more stable? Which one is more stable? Anyone? So 1, 2, 3, 4. This is 1, this is 2, this is 3, then this is our fourth option. Yeah, is that methyl, Yasmina? Yeah, Lima, tertiary. Why? There are three CH3 group. Three CH3 group, it will show plus I effect. So plus I effect, it is giving electron to carbon. So positive carbocation. So positive charge, it will be reduced. The negatively charged electrons are coming, so it will be reduced. So if the charge is decreasing, stability increases. So stability order, it is due to our CH3 group, which is showing plus I effect. So this is the first application of our inductive effect. The stability of carbocation, we can explain using inductive effect. So we have to study this one. The stability of carbocation, that is proportional to plus I effect, right? What about minus I effect? So minus I effect, suppose we have C plus, there is an electron withdrawing group. So here also, electron withdrawing group. Okay, then here also electron withdrawing group. So what will happen? We have to think about that. So CH3 plus I effect, so charge decreases. So that is the thing here. Okay, then so tertiary carbocation, that is more stable due to the plus I effect of 3 CH3 group. Okay, then that is electron donating group, So that's the thing here. Then stability of carbanion. So that is proportional to minus I effect. The stability of carbanion, that is proportional to a minus I effect. Okay, so minus I effect. So what is that? So what is our minus I effect? So here we have CH3 group. It is giving electron. It is also giving electron. It is also giving electrons. Okay, so here there are 3 CH3 group. Here there are 2 CH3 group. Here there is only 1 CH3 group. Then in the case of this one, primary, only H group is present, right? So here the stability, that is different, right? So minus I group. If minus I group is present, then stability will increase. Here plus I group is present. If more number of plus I group is present, then what happens? CH3 is giving electron to this carbon. The carbon is already negative. So CH3 is again giving electron, negatively charged electron. So charge on our carbon will increase. If the negative charge increases, stability decreases. So our tertiary carbanion, it has least stability. So what about this one? Only hydrogen. So we can neglect the effect of hydrogen. So what about this one? Secondary, only 2 CH3 group. It is showing plus I effect. So it is giving electron to our carbon. So negative charge increases somewhat. So now can you tell me, so what is the order? So in the case of carbanion, which one is more stable? Methyl, primary? Yeah, Alima, correct. So primary, that is stable. Okay. So here CH3 group, 3 CH3 group with plus I. So the stability of carbanion, that is inversely proportional to plus I group or electron donating group. CH3 is an electron donating group. So that is a point here. So carbocation stability, carbanion stability. And then our free radical, it is also similar to our carbocation stability, that is proportional to plus I effect. Okay, so that are the applications of inductive effect. These are the applications of inductive effect. I hope this is clear to you. So last class itself, we have discussed the inductive effect, plus I and minus I. Then what about the application of inductive effect? The stability of carbocation, carbanion, and free radical. These are our reaction intermediate. Is that okay, Alima? Is that fine for you? This one, the stability of carbocation and a carbanion. I hope it is fine for you. Then one more application. There are so many applications. Some application we will study next year. Okay, so we will study some of them now, right? So acidity of reagent. So we have an acid Ha, just a representation. Ha, that is our acid. Acid means it will release H plus, right? So H plus is formed, then A minus is formed. So this is acid. Again, the chapter is equilibrium. So acid is giving H plus and some anion is formed, A minus. So we can call it as conjugate base. You will study about that, conjugate base. Okay. So why this chemical bond is formed? It is to attain stability. Right. Similarly, what about here? Why reaction is happening? To attain stability. Suppose this is our reactant. This is our reactant. This is our product. So I'm saying product is more stable. Then reaction will take place. So reactant will say, okay, so let me undergo the reaction. Then I will form the product. So product is more stable. In life also, we want to attain stability. So reactant to product. If product is more stable, suppose our A minus is more stable, then HA, our acid will dissociate to form H plus and A minus. So you have to check whether our acid is very strong or acidic strength is more. One thing you can check, if the acid is releasing more amount of H plus, then we can say it is a strong acid. Or in terms of stability, if the conjugate base formed is more stable, then this reactant has a tendency to form the product. So product, which are the products? H plus and A minus. Same thing here also, H plus is released. So we can say our acid is very strong. So we have to check the stability of A minus. So there are different things in chemical equilibrium chapter. So how to find the acidic strength? How can we say an acid is very strong? One is H plus. If it is releasing more H plus, it is strong. But we can't always say in terms of H plus. So we are using an experimental quantity. So that experimental quantity that is known as Ka. So Ka, that is known as dissociation constant. You will study about the dissociation constant. This A, that indicates for acid. So this is Ka means dissociation constant for our acid. It is also known as ionization constant. Ionization constant. Okay. If the dissociation constant is high, that means acid is dissociated to form H plus. If more H plus is formed, acidic strength is very high, right? So that is the first one. Or in terms of stability of conjugate base, also we can say acidic strength is high, the stability of conjugate base, that is very high. Okay, if it is very high, then directly proportional. Then this point is important. So acidic strength that is proportional to minus IFN. So we will explain why it is directly proportional to minus IFN. Okay, it is inversely proportional to our plus IFN. So we have to find the acidity of the reagent. So we have this acid. So I'm writing the acid, carbon, hydrogen, hydrogen. Okay, here we have a fluorine. Then we have COO minus, right? So it is dissociated from this one and H plus. So this is our conjugate base. So this is our conjugate base. So what about this acid? So we have CH, then one more H. Then it dissociates to form the conjugate base plus H plus. So we can check the stability of our conjugate base. If the stability of conjugate base is more, then acid is strong, right? So the reactant will be converted into product. So how to check that? So check what is the difference between these two. So up to this portion, there is no difference for our conjugate base. So up to this portion, there is no difference for our conjugate base. So what is the difference? Here we have fluorine, here we have hydrogen. So here we have negative charge, right? If charge is high, stability will be low. So charge and stability, charge that is inversely proportional to stability, right? Then fluorine is electronegative. So electronegative means minus I effect, right? So minus I effect, what is that? Minus I or plus I? Minus I, right? So what will happen here? So fluorine is present, so it will withdraw the electron from the carbon chain. So it is taking electron from the carbon chain, negative charge from carbon ring. So what will happen? So the magnitude of charge on this carboxylate ion CO minus will decrease. So charge is decreasing. Okay. Then second case, hydrogen. It is very low. Okay. There's a very weak plus I effect. So we can neglect that. So in this case, first case, fluorine is taking the negative charge. So the charge will decrease. The stability will increase. So conjugate base, this first conjugate base is more stable. Then can you tell me, so which is more acidic, first one or second one? So it is based on charge and stability. So charge is decreasing, that means stability is increasing. Conjugate base is more stable means the acid is very strong. Acid will dissociate to form H plus and conjugate base. So which one is more stable? Can you tell me? Anyone in the chat box? So which one is more stable? First one or second one? First acid or second one? So reason that is minus I effect of our fluorine F group, right? So acidic strength that is acidic strength that is proportional to minus I effect. It is inversely proportional to plus I effect. If someone is giving electron to the carbon chain, then negative charge will increase. The charge increases, stability will decrease. So our acid will not dissociate to form our products. Okay, is that clear? So which is the correct answer? Which one is more acidic here? So can you tell me which one is more acidic here? First one or second one? Which one is more acidic? This is an application of inductive effect. So F group that is showing minus I effect, it is taking electron. So the charge on our carbon C double bond O minus, that is a conjugate base, that decreases. So stability increases. So the correct answer, so CH2 FCOH, it is more acidic due to the minus I effect of fluorine. So that is a reason for this one. So this is acidic character that is proportional to minus I. Acid, it is always negative, right? So that is minus I effect. So next we have to check the basicity of reagent. So I have a base RNH2. It is taking one H plus and what is formed? RNH3 plus. So there is positive charge present. So this is our base. This is our conjugate acid. So what is the difference between base and conjugate acid? They differ by one H plus. So we are adding one H plus to RNH2. Then conjugate acid form. It's a previous year question, right? So conjugate acid base pair. Again, chapter equilibrium. So how to check the strength of the base? So it is based on experimental quantity known as Kb. If Kb value is very high means basic strength is also very high. So what is this Kb? So Ka, that is dissociation constant of acid. So can you tell me what is Kb? So what is Kb? It is an experimental quantity. Using experiment, we have to find the value of Kb of a base. Dissociation constant of a base. So that is known as Kb or ionization constant, we can say. Okay, then again, reactant to product. If the product is more stable, if the product is conjugate acid, so reaction takes place to attain stability. If product is more stable, then reactants will be easily converted into product. So to say the basicity of reagent, we can explain in terms of stability of conjugate base. How to explain the stability? So it is based on electron density, or I can say it is based on plus I effect. So acidic strength is proportional to minus I. Basic strength that is proportional to plus I. So somewhat confusion, right? So we have to take the example. We have to explain that. So we will take the example and explain that. So we have NH3. If it takes one H plus, NH4 plus, then CH3 and NH2. Then last one, there are two methyl groups, right? So can you tell me which one has more basic nature? So the point is the basic character. So basic character that is proportional to plus I effect. So there are one CH3 group. So what is CH3 group? It is showing plus I or minus I. So can you tell me that Alima, Yasmina? So CH3 group is showing, we have already explained that, right? CH3 group that is showing plus I effect. So here there are, yeah, correct. I'm getting the answers in the chat box. Yeah, Alima, great. So this is plus I effect. Here, the first case, there are no CH3 group. Second case, there is one CH3 group, one CH3. So it is showing plus I effect. Here there are two CH3 group, right? There are two CH3 group. So plus I effect is increasing. There are two groups showing plus I effect. So can you tell me the basic nature, the increasing order of basic nature? So which conjugate acid will be more stable? So NH3, it is taking one H plus positive charge. So positive charge is there. So one positive charge is present. Then some groups are attached to that one. If it is plus I group, plus I means it is giving electron. So giving electron negative charge, there is positive charge present here, right? So it will decrease the charge. If the charge decreases, stability increases. So here there are two CH3 groups. So that means which one is more stable? This NH with two CH3 group. If it accepts one H plus positive charge, then that positive charge is reduced by our CH3 group. It is giving, donating electron to the chain. What about the next one? Only one CH3. So it will also give not that much. Okay, that is the second one. The last we have NH3. There are no CH3 group. There are no group showing plus I effect. So the basic nature, or I can say the stability of conjugate acid is very low. So the reason is plus I effect. So this is more stable than least stable or least basic strength. That is our NH3. Is that okay for you? Then the application of inductive effect, which are the applications of inductive effect. So one plus I, then here basic strength that is proportional to plus I, acidic strength that is proportional to minus I, then stability of carbocation, stability of carbanion, stability of carbocation and stability of free radical, that is same. Free radical, it needs electrons to attain octet, right? So group showing plus I will increase, plus I they will give electron, then the stability of free radical will increase. Is that clear to you? You have to revise the things. Organic chemistry, you have to revise the thing, plus I effect. So which group is showing plus I, which one is showing minus I? If plus I is present, it is giving electron. Then what happens to the charge? If charge decreases, stability increases. You have to relate the things. Is that clear to you? Alima, then other JNV students, JNV Pune students, then class 11, okay, JNV Kadapa is there, JNV Patan from Gujarat, yeah, great. JNV Varda is there. Then where is JNV Mahi? Ah, okay. So is it clear to you the applications of inductive effect? These are the different applications of our inductive effect. Okay, Alima, JNV Kohima. Okay, great. So these are the applications. These are the applications of inductive effect. So first electron displacement effect we have studied. So second one is hyperconjugation. So very big name, right? So what is this hyperconjugation? We will just start the hyperconjugation. Okay, hyperconjugation means an sp2 hybridized carbon atom, an sp2 hybridized carbon atom is attached to a sp3 hybridized carbon atom, is attached with an sp3 hybridized carbon atom containing a CH bond, Then what will happen? So electrons in CH bond, that is sp3 carbon, that CH bond will be given to sp2 hybridized carbon atom, Oh, what is this definition, right? So we have to understand that, right? So the point. So what are the requirements? So we need an sp2 hybridized carbon atom, that is double bond. We need an sp3 hybridized carbon atom. Then to that carbon atom, there should be minimum one hydrogen atom attached to that. Okay, we will check it. So hyperconjugation, that is generally seen in alkenes. First one alkenes, second one free radicals, then last one our carbocation. So hyperconjugation, that is generally seen in alkenes, free radical and carbocation, that is AFC. You can remember AFC. Okay, so I will take an example for this one. So I have a carbocation C+. So can you tell me what is the hybridization of the carbocation? So I have a carbocation present here. So what is hybridization of carbocation? What is that hybridization of carbocation? So condition kya hai? There should be an sp2 hybridized carbon atom. So just close to that one, there should be an sp3 hybridized carbon atom, right? Then there should be a CH bond. sp3 hybridized carbon atom should form a CH bond. Then what will happen? This carbon hydrogen bond, there is positive charge present. If charge is present, stability less. So charge means always tension. Okay, there are so many friends. This hydrogen, they are good friends. Okay, so this carbon has always tension. So it is not able to enjoy the life. Then these three hydrogen, they are saying, okay, so I will allow you to enjoy. So I will take all the tension from you for some time and you can enjoy for some time. So they are good friends. So this sp3 hybridized carbon atom. So this is our carbocation C plus. This is attached to this carbon. That sp3 carbon is known as alpha carbon. Okay. Then hydrogen attached to the alpha carbon, that is known as alpha hydrogen. So that is known as alpha hydrogen. This alpha hydrogen, they are very good people. So they will give electron to this bond, carbon bond. Okay. So our resonance, we have studied resonance, right? So electron is coming. So electron is coming to this one. So I can write there is a double bond formed here. Just a second. Okay, we will stop it here. Then we will resume in the next class. Our hyperconjugation. Hyperconjugation we will start in the next class. Okay, I hope today applications of inductive effect that is clear to you. So in the next class, we will start this hyperconjugation and resonance. Okay, then bye-bye. Then revise the things. So organic, it is organic chemistry. You have to, so no homework today. Okay, our time is almost over. So that is why. So no homework today. The next class, we will do the homework question. Okay, then I am ending the meeting. There are so many participants. That is great. So in the next class, we will continue. We will continue our organic chemistry. Then bye-bye, students. We'll see you in the next class. Okay, then bye. Bye.